Good day, we are Group 5 and in this video we will be discussing our design of experiment, which is the 8051 microcontroller ID key verification using EDSIM 51. So we are Group 5 and I am Padilla John Michael Gabriele together with my group mates Chavez Riksha Carnal and Santa Catalina Eliza Jeslyn. So, a brief background regarding our DOE. So, as we all know, the identity of a person is frequently used to identify them. So, we use it in different transactions, such as creation of different identification cards. So, our identity is very important, especially in those parts. So, a representation of an entity that serves as a determining factor is called identity. A digital identity is information stored in the digital world, and this DOE is the application of the learnings in experiments 4 and 5 as a solution to identity verification. So, for our problem statement, so as mentioned earlier, human identity is a very important aspect of life because we use it in almost every transaction that we go through in our everyday lives. Now, identity is very important, especially nowadays wherein everything is digital. So, when it comes to the digital world, we also have our digital identity. So, since these are very important things, we must create a way to protect it, which is why we are continuously creating or improving our authentication processes for the protection of our identity. So our DOE has certain objectives, and those objectives are first, to apply learnings from experiments 4 and 5. Next is to use the LCD and keypad in generating an ID verification. Next is to use the 8051 instruction set to control the LCD and keypad. And lastly is to demonstrate how the simulator can be used for ID key verification. So, however, our DOE has certain limitations. So, for the scope of our DOE, so the scope of this DOE is the use of a keypad to enter a passcode to simulate an authentication process using EDSIM 51. And our limitation is that the limitation of this DOE is that it only uses 4-digit passcodes for authentication. So in this DOE, we are not yet using uh, complicated passcodes such as passcodes that are um, created using letters or words. So in this DOE, we are only focusing on 4-digit passcodes as a way of authentication.
Answers to questions. Number 1. Based on the given instructions, what is the 4-digit password? Based on the given instructions, the 4-digit password is 9921. This code is written under the address org0240H. As you can see on the photo, this is the address and under it is the 4-digit password, which is 9921. Question number 2. What is the output when a correct password is entered? When the correct password is entered, the message "Access Granted" appears in the LCD module. The photo on the screen shows the LCD module when the correct password is entered, which shows the message "Access Granted." Number 3. What is the output when an incorrect password is entered? So when an incorrect password is entered, the message "Try Again" appears in the LCD module. This is the photo when an incorrect password is entered. Question number 4. What happens to the program whenever an incorrect password is entered? So when an incorrect password is entered, the program outputs a message, try again, and the LCD modules and asks the user to enter the password again. The program loops until the user has entered the correct password. Question number 5. What is the output when the assigned password contains letters instead of numbers only? Was there an error in the program? When the 4-digit password was assigned to contain letters instead of numbers, no error occurred in the program. When an incorrect password was entered, the program simply displayed the message, try again, through the LCD module. And question 6. What is the output when the zeros were removed at the end of each lookup table entry? So when the zeros were removed at the end of each lookup table entry, the entries input code, access granted, and try again were simultaneously shown in the LCD module. Also, after entering the correct password, the message access granted was able to appear in the second line of the LCD module as seen here. However, the characters ACC, which were not supposed to appear in the first row, remained. Lastly, after entering an incorrect password, the message try again was able to appear in the second line of the LCD module, as it is shown here. Similarly, the characters ACC also remained in the first row in this case.
Interpretation of results. To interpret the answers provided to the questions, each part of the program encoded will be looked through. The program can be divided into 3 parts based on their starting addresses. The first part of the program has the address org0000H and contains the following program and subprograms. The main program contains the subroutines function, display, and entry that initialize the peripherals and other features of the microcontroller. Next, the again subprogram allows the prompt input code to be displayed in the LCD module and registers the predefined 4-digit code. In the input subprogram, the key is scanned for any inputs whose accuracy with the assigned code is checked. If the entered password is correct, the program proceeds to the accept subprogram, otherwise it proceeds to the reject subprogram. The second part of the program has the address org0200H. This contains the lookup table entries. Its first entry is the prompt for the user to input the code. The second entry is the message for the correct password, while the third entry is the message for incorrect password. The third part of the program has the address org0240H, and this is where the 4-digit password is set. As mentioned, the 4-digit code is written under org0240H. Based on the given program, the password that was set is 9921, as seen in this part of the code. When the input password is correct, the LCD module displays an access granted message. The codes responsible for this are shown on the screen. When the code 9921 is entered by the user, the program moves to the accept subprogram that contains the OK and end subroutines in sequence. The former displays the second entry of the lookup table, which is access granted, and the latter halts the operation of the program. When the input password is incorrect, the LCD module displays a try again message. These are the codes responsible for this. An incorrect password lets the program move to the reject subprogram. This calls the try again subroutine to display the third entry of the lookup table, which is try again, then proceeds to jump to the main program. So when an incorrect password is continuously entered, the program repeats again and again, or a loop is created until the correct password is entered. The password set was composed of numbers only. However, changing this to a 4-letter code is possible since it doesn't cause any error in the program. However, there was also no way for the user to achieve the correct password because each key of the keypad was assigned of numbers from 0 to 9. An example of how the numbers were assigned to certain keys are shown in this figure. Although letters may be assigned to the keys, this may not be efficient since it cannot accommodate all letters from A to Z. If observed, each lookup table entry ended with a 0. Removing these zeros does not cause any error to the program, but puts the entries out of place. This is because the 0 marks the end of the data, specifying that no characters follow after.
For the conclusion, the following objectives were able to be done throughout the design of experiment. Number 1, to apply learnings from experiments 4 and 5, to use the LCD and keypad in generating an ID key verification, to use the 8051 instruction set to control the LCD and keypad, and lastly, to demonstrate how the simulator can be used for ID key verification. It was learned from experiment 4 that the data containing the characters to be displayed in the LCD module must end with 0, while on experiment 5, it was learned how each key corresponds to a certain pin in port 0 that allows it to be controlled. With these, the group was able to apply it to the creation of the design of experiment, or DOE. Lastly, in the design of experiment, it was demonstrated how the simulator can be used for ID key verification through the written program. A main program and several subprograms were created to do so. The peripherals are initialized by the main program. The password prompt is shown through the again and next subprograms. The password is captured and checked by the input subprogram, which leads to either the accept or reject subprogram.